Hi everyone. In this video I'll be explaining negative and fractional indices as showcased in exercise 4 star that we did in class. In this particular video I'm doing number 1 to 16, and in part 2 of this video I'll be doing number 17 to 24. Right, so for number 1 it's a simple question of 5 to the power of negative 2, and when we have a negative indice we need to change it from the numerator into the denominator, and 1 over 5 squared is 1 over 25. For number 2 we've got 4 to the power of negative 3. The same rule applies. It's 1 over 4 to the power of 3, and 4 to the power of 3 is 64, so it's 1 over 64. For number 3, it's a simple matter of just saying 1 over 12, because it's the power of negative 1 and it stays a power of 1 at the bottom but a positive 1. Right, for number 4, we've got a fraction, so a quarter to the power of negative 1, and then we simply flip the fraction to get rid of the negative indice. That means that our answer is simply 4, because 4 over 1 is 4, and 4 to the power of 1 stays 4. For number 5, we've got 2 over 7 to the power of negative 2. First of all, we get rid of the negative by flipping the fraction inside the brackets, and then we have to the power of 2. Right, 7 to the power of 2 is 49, and 2 to the power of 2 is 4. So the answer is 49 over 4. Right, for number 6, we have got 4 over 5 to the power of negative 3. We flip the fraction first to make sure that we get rid of the negative indice, and then we remove our bracket by multiplying or raising the fraction to a power. 5 cubed is 125, and 4 cubed is 64. Right, for number 7, we've got a mixed number. We've got 1 and 2/3 raised to the power of negative 2. Now first sort out whatever is inside the bracket first. Change this mixed number into an improper fraction. We do this by saying 3 times 1 is 3, plus 2 is 5 over 3, raised to the power of negative 2. And then we flip the fraction because we want to get rid of the negative indice. And then we can solve it by saying 3 squared is 9, and 5 squared is 25. So for number 7, the answer is 9 over 25. Okay, moving on to number 8. We have 64 to the power of negative a half. First of all, flip this fraction if you want, because this is 64 over 1, to 1 over 64 to the power of a half. Please remember that it's still a half. You cannot change the value of the indice. The only thing we did now is get rid of the negative. Then we can simplify this fractional indice by taking the square root of 64, because that 2 goes in front there, which is imaginary, we don't write it, and 64 to the power of 1 is still 64. Now if we take the square root of 64, it is 8, so our answer here for number 8 is 1 over 8. Right, for number 9 we've got 16 to the power of minus 1 over 4. Again, first change it into a positive indice. It's 1 over 4, and then you have 1 over the 4 goes here, so you have the 4th root of 16. And if you want to find the 4th root of something, you have to multiply the same number with itself 4 times. So 2 times 2 times 2 times 2 will give you 16. So the answer to that one is simply a half. Right, for number 10, we've got 8 to the power of minus 5 over 3. And that will give us, first we're going to turn it into a positive number. All right, so we've got 1 over 8 to the power of 5 over 3. Then we take the cube root, 1 over the cube root of 8 raised to the power of 5. Right? Then if we get to the 8 to the power of 5, we get 32,768. And if we cube root that answer, we get 32. So our answer for number 10 is 1 over 32. Right, moving on to number 11 next. For number 11, we've got 1 to the power of minus 4 over 3. No need to even work that out. The answer is simply 1. And 1 to the power of anything is 1, because it doesn't matter how many times you multiply 1 with itself, the answer will always just be 1. Right, for number 12, we've got 1 over 81 inside the bracket raised to the power of negative a half. First, we are going to flip what is inside the bracket, so we're going to have 81 over 1 to the power of, the negative changed to a positive, so that's just 1 over 2. And then we're going to get rid of the fractional indice by taking the square root of 81. And the square root of 81 is 9. So for number 12, we have 9. Right, the same law applies for number 13, where you have 1 over 125 raised to the power of minus 2 over 3. First, get rid of the negative indice by flipping this whole thing. So it's going to be 125 over 1 to the power of 2 over 3. Right, and then 125 over 1 is simply 125. We want to get rid of this fraction, so we're going to take the cube root. Remember, this one goes outside the root, and the 2 goes inside the root. Right, if we punch that into our calculators, we get the cube root of 15,625, and the cube root of that is 25. So the answer for this one is a good 25. Right. Moving on to number 14. 14, we have 27 over 8, all raised to the power of negative 4 over 3. First of all, flip the fraction so that you can get rid of the negative 1. So you get 8 over 27 raised to the power of 4 over 3. Now you have two options. You can take the cube root and then take the 8 to the power 4 and 27 over to the power 4. But I would suggest is rather simplify whatever is inside the bracket first. So you know that make it to the smallest possible base number. So you've got 2 to the power of 3, which is 8. And you've got 3 to the power of 3, which gives you 27. And you raise that to 4 to the power of 3. What happens now is the raising of powers. So the raising of powers is when you have x to the power of a and you raise it to the power of b, it simply becomes x to the power of a times b. So the same law is going to apply here. You are going to have at the top 2 to the power of 3 times 4 over 3, right? And at the bottom you're going to have 3 to the power of 3 times 4 over 3. And now I'm simply talking about the indices. Okay, so if I want to blow that up for 1 minute, we can see that, forget about the brackets for a minute. If we have the 3 times 4 over 3, let's put this over 1, we're going to get 12 over 3, which is going to be equal to 4, right? So that part will simply be 2 to the power of 4 over. And if we multiply, now ignore this part, let's just clean it up a little bit. And if we look at this, just look at the indices for a moment. If we've got 3 over 1 times 4 over 3, we get 3 times 4 is 12 over 3, which is equal to 4 again. So we've got 3 to the power of 4 at the bottom. Right. And this makes it a lot simpler. It makes it a lot simpler to work it out like this than to work out the whole thing otherwise. Right. So then you are simply left with 2 to the power of 4. 2 to the power of 4, which equals 16, and 3 to the power of 4, which equals 81. So your answer for this one is 16 over 81. It's much better to simplify it like this than to work with large numbers. Okay, moving on to number 15 then. And number 15 gives us 162 over 32, right? And that is raised to the power of minus 3 over 4. First of all, get rid of the negative 1, and we do that by flipping the whole fraction. So we've got 32 over 162 raised to the power of 3 over 4. Now first simplify whatever is inside the bracket. So I would simply divide by 2 to give me 16 over 81, right? 3 over 4. Then I would again simplify this. 16 is equal to 2 to the power of 4, and 81 is equal to 3 to the power of 4. Now, be careful. You cannot simply subtract these indices from one another because the base numbers are not the same. So the fraction stays the same. But again, we can now raise the indices power. So what's going to happen is we're going to have 2 to the power of 4 over 1, which is that 4, times 3 over 4 at the top, and at the bottom we're going to have 3 to the power of 4 over 1 times 3 over 4. The 4's will cancel out, and we're going to be left with a 2 to the power of 3 at the top, and at the bottom we're going to be left with a 3 cubed. 2 cubed is 8, and 3 cubed is 27. And that's the simplest fraction that you can write the answer in. Right, for the last question, question 16 on this exercise, we are going to start by saying 2 divided by 32 to the power of negative 1 over 5. Right, 2 stays the same, the division stays the same. Simplify this 32 so that it is a 2 to the power of. So 2 to the power of 5 will give me 32, and then this will just become outside of the bracket. Rewrite this whole equation into a fraction. So 2 divided by 2 to the power of 5 raised to the power of negative 5. Right. Now multiply these with one another. 5 times times negative a fifth will give you 2 at the top, and at the bottom it will give you 2 negative 1. Now the negative 1 can go to the top, so we've got 2 times 2, and that will give me 4. If this is a negative 1 at the bottom or in the denominator, it will become a positive 1 in the numerator. And that's why this can go up there, and that becomes a multiply. Right, so that's where that part comes from. And that is your answer for number 16. For questions 17 to 24, please go to part 2 of exercise 4 star numbers 1.